Complex numbers is one of those chapters that has a lot going on in it. Many a times, there are questions that look very lengthy on first glance, but which can be solved very easily if you know all the properties of conjugates and modulus of complex numbers. Now, if you already have an idea about those properties, or if you already have some basic understanding of complex numbers, you can skip the theory part and move straight to the question that we will be discussing. But if you have never studied complex numbers, you can watch the video from the very start because I will be explaining it from the very basics and we will slowly move on to the advanced level that is required for JEE Advanced. Now, when you were kids, the first thing you learn in mathematics is counting. Now, back then, you were just counting. You did not know that 1, 2, 3, 4, and so on are natural numbers. After a while, you are taught fractions in which you have numbers like 3 by 5, 7 by 16. You did not know back then, but these were actually rational numbers. Then do not move directly to irrational numbers. If you are aware of it, in algebra, you will be exposed to negative integers from, let's say, class 6th or 7th, and so you know what minus 3 is, what minus 8 is, and so on. And finally, you are exposed to irrational numbers under root of 2, pi, e, and so on. So, if you have studied theory of equations, you must have come across conditions in which we say that we have imaginary roots. In that, we do not say anything more about it. We just say that d is less than 0 and we solve questions based on it. However, what exactly to do after it? Because they are representing something, right? So we'll have to study them more. So the problem begins whenever you have equations like this one, where d is less than 0. So if you factorize it using quadratic formula, you can easily reach till this stage. But the problem then is, what to do with this under root of minus 3? To solve this, we can use a basic rule from maths which says that under root a into b is equal to under root a into under root b only when either of a or b is positive. What this means is a and b both cannot be negative at the same time, otherwise we get false solution. However, if both a or b are positive, or if either of a or b is positive, so basically this can be written as 3 into minus 1. So we can write under root of minus 3 is equal to under root of 3 into minus 1, which is root 3 into under root of minus 1. This quantity, this we term as iota or I, and once we introduce this, we can solve almost everything in complex numbers. The solution becomes minus 3 plus minus 3 root 3 I by 2. So basically the problem was how to deal with quantities like this. Basically, any complex number can be written as z is equal to a plus ib. Z is how we commonly denote a complex number, where a and b both have to be real numbers. The I part is what makes it complex. Now remember, even though we called a and b as the real and imaginary parts respectively, I is not the imaginary part, b is the imaginary part, which will be a real number. So if you think about it, all these numbers are also complex numbers, but the thing is, imaginary part is 0 because you can write 1 as 1 plus 0 iota. Similarly, you can write root 2 as root 2 plus 0 iota. So basically all these numbers are also complex numbers, or they are subset of complex numbers. So every real number is also a complex number. Now based on this, we define two things. First, the conjugate of complex number z, which is denoted by z bar, is a minus ib. Basically, you reverse the sign of the imaginary part of the complex number z, and modulus is under root of a square plus b square. Now, you can understand this graphically because any complex number can be understood as having two parts. Let's say this is the real axis and this is the imaginary axis. These are basically x and y axis, but re- we are understanding them with respect to complex numbers. So basically any complex number is the point a comma b where x axis will be the real axis and y axis will be the imaginary axis. You can understand in this way. The specific terminologies are different. So this is the complex number. A conjugate basically means its reflection about the real axis. So since it's a comma b, the reflection will be a comma minus b. That is basically what conjugate means. If the point would have been here, the reflection would have come here. The x component remains the same. We only change the direction of the y component. If this would have been the original complex number, its conjugate would have come here. And under root of a square plus b square, which is the mod of the complex number, is nothing but its distance from the origin. This is under root a square plus b square. This is what you were taught in vectors also. Complex numbers can also be understood in terms of vectors. So if you have understood this, you can solve a lot many questions which are created by mixing complex numbers and geometry. It can be straight line, it can be conic sections, it can be vectors even. And this is what makes this chapter so interesting and so big, right? Because so many things are involved in this. Also remember that you are not adding these two. It's not an addition as in 2 plus 3. This is just a symbol. We cannot add 2 and 3 iota. This is just how we represent it. Now, we can manipulate z plus z bar, and what we will get is a plus ib plus a minus ib, because in the conjugate of z is a minus ib. We get 2 times a, which is 2 times the real part of z, because a is the real part of z. Similarly, z minus z bar will be a plus ib minus a plus minus ib, which becomes plus. So this cancels out and we get 2b into I. So if z is equal to z bar, we get a plus ib is equal to a minus ib, or b is equal to 0, which is a purely real number. So basically, all these numbers are purely real numbers because the imaginary part is 0. And if z plus z bar is equal to 0, which means z is equal to minus z, we get a is equal to 0, or we get a purely imaginary number, which means the number will be of the type 4 iota or minus pi iota and so on. There is no real part here. So, if you have understood the graphical representation of it, what this means, purely real numbers will lie on this axis. Every single point will represent a real number, because here the imaginary component or the y component is 0. Similarly, every single point on this axis will represent purely imaginary numbers, because the x component of that complex number of all those complex numbers will be 0. Next, we have some properties of conjugates which you can easily derive if you just substitute a with z and z2 here. Basically, when we take the conjugate of z1 plus z2, the bar is just distributed over each complex number, and it doesn't matter if it's plus or minus, it gets distributed evenly. So if we have, let's say, z1 minus z2, and if we take whole bar, it will be nothing but z1 bar minus z2 bar. So basically that's how I've written it, to show that it doesn't matter if it's plus or minus. You can just put it on individual terms, and you can easily derive this. You can take z1 as a1 plus b1i and z2 as a2 plus b2i, and when you add it, you will find that we can easily connect a1 and b1 terms. Similarly, for multiplication, the bar gets distributed, and the same is for division. Again, you can cross verify it by taking different complex numbers, and when the final answer comes, you can check whether this formula holds or not. Now, the other thing is what I defined to be the modulus of the complex number under root a square plus b square. Now when you multiply z into z bar, that is a plus ib into a minus ib, you get a square plus b square, because basically this is x plus y x minus y, which is x square minus y square. However, because of this iota, you get another iota square, and iota square is minus 1. So that minus 1 sign gets multiplied by this minus sign, and you get a plus sign here. So you get a square plus b square, which is nothing but z square, or the square of the modulus of z, because modulus of z is a square plus b square, right? So z into z bar is equal to z square. Now, if you have understood everything till here, you can actually solve some questions of JEE Advanced through simple manipulation of these results. So let us take a question which was of JEE 2022, JEE Advanced 2022. Let z be a complex number with non-zero imaginary part. If this is a real number, then find the value of modulus of z square. Now, as I said, the topic of this video was how to manipulate z, z bar and mod of z to solve questions. So, if you would have come across complex numbers for the first time, your first hunch would be to substitute z as a plus ib or x plus iy and then solve it completely. But it can get very lengthy. So, using the properties we have just studied, the question reduces a lot. Basically, first of all, you can see that there is a symmetry in the denominator and the numerator. So, we first have to reduce this in terms which is fairly easy to calculate. So, we take it here. 2 plus 3z plus 4z square upon this. Now, this term you can write in terms of denominator, so the denominator cancels out easily. You can write this as 3 times z plus 6z, because that will again be plus 3z. So we write 2 minus 3z plus 4z square plus 6z. So when we solve this, this entire term can become 1 and we will get this term. So this simplifies as 1 plus 6z upon 2 minus 3z plus 4z square. Now in the original question, this entire term that we have just simplified is a real number. So what does this mean? That its imaginary part, that is when we express it as a plus ib, this part, that is b, has to be 0. And what do we know of numbers when those are purely real? Z is equal to z bar, because b is equal to 0, so z will be equal to z bar. So for purely real quantities, we will simply get this, that is the original term, and its bar are the same. And as we have seen from here, these terms get easily distributed over denominator and numerator and plus and minus sign. So basically, this entire term is purely real. Now 1 is purely real, so just leave it. We will focus on this part. 6z upon 2 minus 3z plus 4z square also has to be purely real for this entire thing to be purely real, because 1 is already purely real, so this quantity has to be purely real. So whatever complex number this is, that let us call it z1. So for z1 to be purely real, z1 bar has to be equal to z1. So z1 is basically this term 6z upon 2 minus 3z plus 4z square, and its entire bar. So we will just distribute bar on individual terms: 6z bar, 2 bar, 3z bar, 4z square bar, and 2 bar is basically 2 because it's a purely real number. So it's basically 2 plus 0i. So its conjugate will also be 2 plus 0i. So 2 minus 0i, which is 2 basically. Now we cross multiply it and we get this equation. We simplify it. You can try it, it is very easy. You simplify it, get 2 into z minus z bar into 1 minus 2z z bar is equal to 0. Now, so we have two factors. Now, either one of these can be equal to 0. So the first thing is either z minus z bar is equal to 0, which implies z is equal to z bar. But remember, the original complex number z has a non-zero imaginary part. So this means we cannot have this condition. Z cannot be equal to z bar. Otherwise, it would have been a purely real complex number, but that's not the case. So with because it has a non-zero imaginary part, z is equal to z bar cannot be true. So this factor cannot be 0. So this we will have to look into this other factor. Now, so 1 minus 2 into z bar is equal to 0. And again, z bar is another term which we just saw recently. Z bar is nothing but mod of z whole squared. So mod of z whole square is half, which is what was the value you were required to calculate in this question. So you see, just by knowing the very basics of complex numbers, we were able to solve a JEE Advanced question. And you could solve it easily only because you knew the relations between z bar, and mod of z whole squared. What it means when a complex number is purely real, what it means to have a non-zero imaginary part, what z square is. If you only know the properties that you have studied now in this video, you can solve some questions of JEE Advanced. Similarly, there can also be other expressions. Suppose you are given mod of z plus 2 z bar is equal to z, and you are called to comment upon the nature of z. Now, one thing can be that you can assume z to be a plus ib, and then this equation will become mod of z square, which is a square plus b square plus 2 times a plus I, sorry, a minus ib, because it's conjugate, right? A minus ib is equal to a plus ib. So from here you can collect all the real parts on one side and all the imaginary parts on one side, and if two complex numbers are equal, the imaginary part of this side will be equal to imaginary part of this side, and the real part of this side will be equal to the real part of this side. You can solve it that way, but it will be very lengthy. And the motive of this video is to show you how you can simplify such questions if you know certain properties of conjugates and of modulus. What you will do is basically take conjugate of this entire equation, because conjugate is something that breaks evenly. So when you take conjugate, you get, now this is a, see, z is nothing but distance. It is under root a square plus b square. It's a purely real number, and the conjugate of a purely real number is the same number. Plus, now this term was 2z bar. So what this means, this will be a plus ib, its conjugate will be a minus ib, and its conjugate would again be a plus ib. So this term will be nothing but 2 times z. Basically, if you have a complex number z and you take its conjugate 2 times, you will get the number back again, because it will be a plus ib, which will become a minus ib, which will again become a plus ib. So you get back the original number, and z will become z bar. That's the easy part. So basically you get another equation, which is mod of z plus 2z is equal to z bar. This was the first equation, mod of z plus 2z bar is equal to z, and this is the second equation. You basically subtract these two. So what we will get is, let me just write it here again, you know. Just subtract this from this. This will cancel out. 2 z bar minus z is equal to z minus z bar. You move this, you move these terms here. You will get z bar minus z is equal to 0. Z bar is equal to z, which means purely real. So we were asked to comment about on the nature of z, and this simply means that z is purely real. So again, you can simplify many equations and many questions if you know, and if you keep in mind the basic properties of certain complex numbers. And again, you can find such equations in complex questions in JEE Advanced, and you can save a lot of time if you know these manipulations beforehand. So this is what this channel is all about, right? We teach you theory in a way that is aimed at solving questions of JEE Advanced. Theory is important, no doubt, but we need to add some more value to it. Don't get me wrong, theory can always be studied for the sake of studying theory, but when you're preparing for a competitive exam, or when you're trying to solve maths in general, it doesn't matter if you're studying maths for JEE or if you are using maths for physics. The ultimate aim is often to solve problems, right? So it's not like we are moving you ahead from pure theory, but you have to study theory from a point of view that you should be able to solve real questions. And that is what this channel is about. So please subscribe for other lectures as well, where we will take specific topics and study them in a way that helps you tackle difficult JEE advanced questions. Basically, we will take absolute basics and then move to advanced level simply based on theory.